And today we have Naomi with us. We are very excited to have Naomi. And I just want to say a little bit about Naomi. So Naomi did her undergrad at the University of Cincinnati in mechanical engineering and Spanish, and holds a PhD in robotics from the University of Pennsylvania, where she worked in a grasp lab. Naomi was also a postdoctoral scholar at USC. And I also want to mention that Naomi is a member of the Collaborative Robotics and Intelligent Systems Institute, or CoRIS, where she investigates ways to equip robots with the ability to engage and empower people. Well, what this means in reality is that Naomi did a super cool work on playful high five with robots and other beautiful work. Right now, Naomi is an assistant professor at Oregon State University. She's the founder of the SHARE Lab, where she studies socially assistive robotics, haptics, and robotics and the arts. A curious fact, Naomi is a stand-up comedian, as you by now know. In her website, she describes herself as a roboticist, educator, and performing artist. And it is incredible for us to see how Naomi combines a variety of expertise and talent, making her an inspiration for all of us, because I think that's really a holistic view of a person. So now I'm giving it away to Naomi, and she will be talking about everything she knows about telepresence robots.
Thanks for that awesome intro, Patricia. Let's see, I will queue up my slide deck after sharing properly. Even after several months of online teaching, I still am subject to failure, but hopefully now you see my opening slide. Excellent.
Yeah, it's all good.
Sounds good. So, hey everybody, I'm excited to be part of this Talking Robotics series. As Patricia said, I'm Naomi Fitter, an assistant professor at Oregon State University, here to share everything I know about telepresence. And I thought I'd share kind of an opening warning that I'll fit a lot into this talk, so it'll be kind of a whirlwind. And I figure this will be more interesting for the later discussion component, but I'm happy to circle back to whatever kind of caught your interest and answer questions and talk about it more in depth then. So take good notes, I guess, and we'll come back to some of these themes later. My work generally focuses on using robots to promote people's health and make them happier and more connected. And the work presented here was mostly part of my postdoctoral work at the University of Southern California, which focused on socially assistive applications of telepresence. And I guess we all know by now, but between remote classes at universities, employees working remotely from home or far distances, and even the current medically related pressing need for social distancing, compelling communication over long distances is of great interest and relevance nowadays. And telepresence robots have a unique ability to connect people who are physically separated from school children who are not able to attend class in person, maybe for health reasons, to far apart relatives or remote employees of companies. So why aren't these robots everywhere yet? Where could they be more useful? How can we enhance existing technology? These are some of the questions I tried to cover in my past telepresence work. And this talk is structured to touch on 4 main topics related to answering some of these questions. I'll cover mainly telepresence for remote education, kind of hidden key factors in the telepresence experience, control of telepresence hardware, and also some turn-taking or floor-holding type topics with telepresence robots. So here's just diving into the first of those topics, a bit about telepresence in education. So even before the pandemic, 29% of university students used remote learning tools, with 14% taking all their classes online. Now, obviously, the rate is even higher, and it feels kind of funny to even relay some of these facts. In usual operations or current times, as classes return to blended operations, maybe many students might still need to be attending classes remotely. So it's easy to wonder, either nowadays or just thinking about remote education in general, how in-person learning through traditional distance learning tools, and learning via a telepresence robot might compare. So this work kind of centers on that to better understand the effects of telepresence robot-mediated education. We conducted a within-subject study, and we studied the experiences of 18 students who attended engineering classes using 3 different methods in person, kind of depicted here, via existing distance learning tools, so kind of your nice video streaming that goes to the student with some Q&A chat type features, almost like Zoom currently, and using a telepresence robot, so having a physically embodied physical proxy that you can use to video conference and also move around the remote educational space. And participants used each of these methods for 2 weeks in an order counterbalanced across the study. I'll zoom through a lot of these studies, but I want to usually share the design and the measures. So measurement-wise for this study, in the opening survey and interview, we gathered some demographic information and background about participants' tendencies as a student generally and past experiences with distance learning. After each day of attending class, participants also completed a survey about their ease of learning and presence feelings in class that day. After each condition, so the in-person, distance learning, or telepresence mediated learning, participants completed survey questions also about their presence feelings during that condition and free response questions about their experience generally. And then periodically throughout the study, at the beginning, end, and between conditions, we administered a milestone survey that was a little more in-depth about general characteristics about the learning method from the previous 2 weeks classes, for example, safety or trustworthiness of the experience. And there was a closing interview to further understand participant experiences throughout the study. So in interest in zooming through, I'll often skip kind of right to the key results or significant differences that we saw in this work. In this case, our collective quantitative and qualitative data showed that during in-person learning, students felt the most present, able to express themselves, aware of classroom happenings, social and able to interact with classmates, and also engaged compared to all other attendance methods. So in-person certainly has some gains. We know, especially nowadays, that this isn't always possible though, so worth comparing how those other distance learning methods stack up. Ease of learning is also certainly of interest. Generally, we're often wanting students to learn through classes, whether they're remote or in person. So we saw that ease of learning is very good during in-person learning and also through kind of the current distance learning tools, especially for students who are taking classes here using English as a second language. I think the ability to rewind and rewatch the class content was really helpful. And comparing different remote learning tools, we saw that telepresence robots do have some edge compared to the traditional distance learning. They led to better presence feelings, self-expression, and participation outcomes, while the more existing remote learning tools were more trustworthy, straightforward, and reliable and comfortable to use. So a little bit of a glimpse at those differences across in-person, distance learning, and telepresence mediated education. Currently, it seems like telepresence robots have an edge over traditional remote learning in situations where students might need to roam the classroom and engage in interactive work, but they fall short when it comes to ease of use and even being helpful for learning during lectures. So if we want to keep improving telepresence usefulness in education scenarios, I think it will be a good idea to do the following things. This is partly based on some of our observations throughout the study, the direct results themselves, those significant differences, and a lot of the interview or survey feedback. It seems like we need to provide better training or onboarding exercises. These systems are harder to use than remote video streams, so users need a chance to build their skills in kind of a non-intimidating way. Also, we'll need to make sure these systems are reliable. It doesn't matter if you have these extra fancy features like degrees of freedom, ability to move around the room, signaling modalities, if the system's unreliable. Speaking volume, self-awareness also seems to be key. So a lot of feedback to the telepresence operator isn't quite there yet. I think even Zoom nowadays has some nice features for this, most of which aren't yet there in the telepresence robot system. So giving that self-awareness can help users feel more confident and comfortable. The camera quality is also super essential, quality and field of view. If the users aren't having as good of an experience with their video conferencing as they might have through like a video call on their phone, it's going to be very frustrating and hard to learn. And some new and relatively simple features for back channeling between teachers and remote students also seem to have potential for enhancing the remote learning of both parties. Both the professors who we talked to during the course of the study and the students themselves wanted kind of a subtler way to get the professor attention. So things like lights around the screen of the telepresence robot to indicate if the student had a question or understood could be really helpful. So that's kind of a whirlwind through that first topic. Happy to circle back if folks have questions about any of that. But I'll go ahead and shift gears a bit and touch on kind of some hidden yet important factors in telepresence that I observed throughout some studies of this topic. So humans often personalize technology, from Roombas to phones to industrial robots, and personalization can lead to different feelings toward or experiences while using a robotic system. So in this project, we were curious if personalization would affect experiences using a telepresence robot for the robot operator themselves and/or for local co-present people with that robot hardware. To better understand the effects of telepresence robot personalization, we conducted a between subject study with pairs of participants, and the pairs completed 2 activities in a counterbalanced order, kind of a navigation through obstacle course task and collaborative puzzle solving, sort of proxies for moving around the physical space of the school and maybe completing collaborative peer work problem solving. In this between subjects design, there were 2 groups. First, 16 participant pairs who used a non-personalized robot during the study activities, and 16 who used a personalized robot. And again, sort of running through the measures we used, there was in an opening demographic questionnaire, in particular, some participant rating of closeness with their teammate, which we thought might be interesting in this study as a potential covariate. After each study activity, we also asked some self-presence and ownership questions. These come from the virtual reality field mostly. We tried to pick the closest validated surveys we could find. And we also video recorded the study activities for coding physical assistance behaviors between the co-present participant and the robot. If they got stuck in that obstacle course, what kind of happens there? And our hypotheses going into this work were that the robot operator would feel more present when the robot's personalized. The co-present person would perceive the robot operator as more present when the robot was personalized. And the co-present person would help the robot more when it's personalized, maybe feeling more of that natural connection with your peer or friend. The results, though, did not support any of these hypotheses. We didn't find any relevant statistically significant differences. So we were a little puzzled. We were looking a bit more at the data, and in some exploratory post-hoc analysis, we considered 2 covariates that were correlated with certain study measurements: relationship closeness of the pair and video game experience, which is another thing we asked about in that opening survey. And relationship closeness in particular turned out to matter quite a bit. And COVA tests show that pairs with a closer relationship spent more time and used more items during the study personalization activity, choosing what to put on the telepresence robot. And robot operators also felt more present just from having a closer pre-existing relationship with their teammate. So regardless of what's really on the physical robot hardware, that sort of led to more feelings of closeness. So we wanted to get at this a bit more. Those results from the past slide come from exploratory tests, so we wanted to design a follow-up experiment that could reinforce and kind of pinpoint these findings more deliberately. And in this follow-up between subject study, we again had participants work together to navigate around a space and complete a collaborative activity. But this time we made relationship closeness the central manipulation by recruiting 12 participant pairs who were acquaintances and 12 who had close relationships, so kind of manipulating that closeness factor. And we gathered the same relationship closeness and self-presence and self-ownership data as in the previous study. And we also recorded participant performance in the collaborative activity itself, which in this case we used the subarctic survival problem. And our hypotheses going into this study were more centered around relationship closeness now. So we thought, based on those exploratory analyses last time, that a robot operator might feel more present if they had a pre-existing close relationship with their teammate, that presence perceptions of a co-present person would not be significantly affected by pre-existing relationship closeness. We had seen that effect last time for the robot operator, the one who's controlling the robot, but actually not for the co-present person. And we also thought participant pairs would work more effectively together if they had a pre-existing close relationship. And in this follow-up study, all of these hypotheses were supported. So we finally were able to pinpoint something related to what we were investigating, as described further in that closeness is key over long distances paper. So what does this mean for telepresence generally when we look at all this together? We found relationship closeness to have a significant effect on the robot operator's feeling of presence and a mixed team's performance. I think this is key and interesting because this type of technology might often be used to help people meet for the first time. So thinking about the implications of that, is there a better way to orient people and get them connected before jumping to telepresence? That might actually be a valuable or important approach. We did not identify significant effects of personalization, but this research area still merits some further exploration. We've looked at personalization with telepresence actually a few different ways now, some with more decorative or sticker-like personalization with younger kids for whom personalization might be more important. This particular study was with adult participants and more human-like personalizations like the hats or shirts you might see on telepresence robots around an office. But so far, we haven't quite been able to isolate the effects. Perhaps some ongoing work there. And the results of our follow-up study showed that relationship closeness is more impactful for robot operators than for co-present people. I think this is interesting because it might influence where the robot hardware is placed in a system. For example, remote coworkers might feel a stronger sense of presence in the workplace if they're able to sit close to or interact with close colleagues as opposed to wherever it's convenient to place the charging station. So some things to think about as we place telepresence robots. And as a brief aside, I mentioned there's more to do in this personalization space, perhaps more to investigate. I'm still working on this problem a bit, and I wanted to mention briefly that we think particular specific personalizations can help make or break the telepresence experience too. So generally, personalization in an in-person study, I haven't been able to find any significant effect of that yet, but when doing a photo-based online M.Turk study, we were able to isolate kind of a negative effect of wigs So wigs do seem to have a negative effect on perspective interactions with telepresence robots, although the action of telepresence robot personalization overall, as long as users don't use a wig, seems to be positive. It's as positive as a non-personalized robot in most categories, and also adds to human likeness, which in certain cases may be advantageous. So that's a bit of an aside. And now I'll shift gears a bit again. I want to share a little work on expressive hardware for telepresence robots to start rounding things out for the talk. So back in the remote learning study, one piece of feedback from students and professors was the desire for better nonverbal signaling or back-channeling, like I'd mentioned. And past related work shows this need as well. A good example, I think, is when a remote participant in a conversation using a telepresence robot had trouble interjecting, or maybe people might want to point at something, gesticulate to help hop into a conversation. So the idea of adding this type of expressive hardware to telepresence robots is not new, but no past designs in this space seem to have yet been widely adopted. So it's kind of an interesting space to think about. So we decided to back up and add some new expressive hardware to an Omni Labs Omni robot. You can see one moving around in action here, perhaps in the video. Oh yeah, it is going. So we wanted to see how study operators could control additional hardware on this type of robot and investigate its usefulness. We added a gesturing arm and LED lights to this robot, the OmniLabs Omni. More details about this system engineering are in the associated paper I'd mentioned, but in case you're interested in developing this type of platform, you can check it out. So in this first related work on new expressive hardware for telepresence, we wanted to study how robot users could control the 3 degree of freedom arm, that arm on the telepresence robot. And even with robot arm functionality, it wasn't clear how to allow the robot operator to control the arm in addition to typical robot function. Telepresence users are already monitoring a lot simultaneously, so often they're actively monitoring or thinking about 2 remote camera streams. Sometimes they also have a self view. You can see some of those views in the images on this slide. They're doing keyboard and or mouse function typically, often socially interacting with others in the environment, and navigating and controlling different application menus. So it's a lot to keep in your head at once and control, I think a pretty formidable challenge. And based on related work in telepresence peripheral control and teleoperation interfaces, the main 3 methods seem to be screen-based GUIs or graphical user interfaces, non-actuated versions of the robot that you can kind of move around that match the geometry of the robot itself, or motions of one's body. So maybe I'm moving my actual arm to control the robot's arm. So we engineered ways for Omni Robots users to control the robot using each of these methods: that on-screen slider-based graphical user interface, a physical dial, so sort of a non-actuated proxy for the robot's geometry, and a Connect camera-based control where you can move your arm around and have the robot's arm match your motion. So our focus in this study was to compare the different interface options in a more controlled way than past work in this area. A lot of the time we had seen just one of these types of control used, maybe with a few different mapping within that particular type of control. So we didn't have much clarity on which was really the best option for controlling telepresence robot peripherals. Here you can see a quick demonstration of the study activity, which entailed a team snack packing activity during which the remote participant gestured to a local Confederate, and 12 participants completed this activity, with each trying all 3 user interfaces, so within subject's design. After each round of the study activity, each of which, as I mentioned, involved a different arm control interface, we asked participants questions from some validated surveys, so trying to get at task load of controlling the interface, perceptions of self and self-presence, so the same types of questions from the virtual reality literature. And we also interviewed participants about their experience at the close of the study. The overall results so far indicated that between the three considered common user interface strategies, the physical turning dial had some advantages. It was lower effort as an interface and had advantages over the on-screen control option. In gesture-based nonverbal expression for telepresence robots, we suggest thinking about this strategy and trying it out. I think it might be one of the least common strategies in the literature, but the physical UI separate from the screen that doesn't require user motion of their own limbs, at least not to an extreme extent, seems to offer some advantages. So consider things like UIs made of non-actuated replicas of the robot's arm. At the same time, though, before prescribing this approach for all interactions involving gestures and longer-term use cases, I think more follow-up work is needed. Longer-term studies in the wild is something I'm prioritizing in my current work and that I hope to see more commonly in the robotics research community as well. That'll be really where we're headed to see how we can enhance robots in everyday spaces. And one more quick piece of work related to that, expressive hardware for telepresence robots, building on the past work. We also wanted to study perspective turn-taking solutions for telepresence robots. So now we know a little bit of how we might use or control expressive peripherals for telepresence robots, but what are they actually useful for? Are they able to make a difference in the areas we envisioned? So now we had this expressive hardware, we wondered if we could use it to address one of those problems that I mentioned seen in past telepresence interactions. In this case, we were specifically thinking about difficulty interjecting and the commonness of getting talked over, which a lot of us have experienced, I think, with Zoom as well. It's not a unique problem to telepresence robots. And accordingly, our key question in this last work was, what are the contributions and implications of expressive turn-taking hardware on telepresence robot-based communication? Can we help somebody take the floor, take sort of charge of the conversation through this type of hardware? And we performed a within-subject study involving pairs of participants who completed a mock subarctic survival activity again. 24 pairs of participants, so 48 people, completed these activities together with one party using the robot and the other person as the local co-present with the robot participant. And we compared expression with no hardware via LED lights and via arm motion. So I have some little videos. You can see briefly on the leftmost one, no extra expressive hardware in play. In the middle one that's playing now, there's a little blue light moving around the screen of the robot. So kind of an indicator of I'm taking my speaking turn.
Subarctic.
And in the last one, you can see sort of arm-based gesticulation, that beat gesture to help the robot user take the floor. And both parties in this study also answered relationship closeness, self-presence, and self-ownership questions. And we had some behavioral data again from the results of the teamwork activity. And findings and conclusions this time were among participants who preferred the arm-based expressiveness, individuals in both study roles saw that the robot operator was more in control of the robot, and participants co-located with the robot felt closer to their teammate during the arm-based condition. So maybe for people who naturally use that type of gesture in their everyday expression, this is a helpful solution. LEDs seemed more helpful kind of as a notification, maybe it's more useful as feedback than for kind of butting in and taking the floor. And they also, it looked like the arm also made the robot seem more human-like. And for this study, I think there's also kind of a next step that I didn't get to during my postdoc that might be interesting. Extra nonverbal expressive hardware for telepresence robots has some benefits, but they may be more important in group interactions than in one-on-one interactions. I think in most cases, the conversation flow and turn taking wasn't too challenging to do in this case, so maybe a future study with a bigger group would show more inherent benefits or advantages of this type of hardware. So here's kind of a final digest slide. A lot of the main things I think I learned from a few years of digging into telepresence. One big one is that camera quality thing that I had mentioned before. Network connection is closely related in many cases as well, but this is essential. If the two-way video of the robot is worse than Skype or FaceTime, users are very likely to be unsatisfied. For distance learning applications, telepresence don't quite yet seem to be always better. Robots do provide more feelings of presence in the classroom, but they're also significantly more daunting to use. So they might be the right solution some, but not all of the time, at least in their current form, the current commercial state of the art. Personalization, although we really believed in it, seems to be of limited importance so far, especially compared to other factors. Physical personalization of telepresence robots seems to have minor effects. Among the most important ones are deterring qualities of wigs and ultra-human-like enhancements, but the general personalization of the robot does seem to have a small benefit, making the robot more human-like generally, as long as you don't use a wig. It's positive and human-like. Interpersonal closeness of relationship is key, so remote robot operators feel significantly more present just based on their relationship with people in the remote robot space. So that's something to consider when we're placing robots and deciding which end of the system we want the robot to be on, who the robot operator should be. Operator task load is very high to begin with, so we can possibly add new expressive hardware to telepresence robots, but it's tricky to add it and also have operators successfully control it. We had the best luck controlling an expressive robot arm using a non-actuated physical input device, but I think a little more study is needed there for more resounding conclusions, especially in terms of longer term use. And expressive hardware may be helpful in groups. In one-on-one interaction, it did have some effects, but maybe not yet enough of an impact to merit its widespread introduction. I think it's worth exploring in larger group interaction. So if you're studying telepresence and interested in this type of thing, feel free to steal that study design. And a final thanks, I wanted to shout out to some folks who helped out with this work, especially Liz Cha and Maya Macharich from University of Southern California, and Leila Takayama from UC Santa Cruz, who contributed to a lot of this work. Also many other co-authors you can check out on the papers. This work was supported by the US National Science Foundation, and Omni Labs also provided hardware to assist with the work. I think that's a wrap. Yeah. Thanks for listening, everybody. And I'm happy to chat and answer all your questions.
Thank you so much. It was very, very interesting. I want to open now to questions from the audience that you can have. You can just unmute yourself and jump in, or raise your hand, or even write in the chat.
Perfect talk.
Okay, so I actually have a few questions. So let me see here, because I have many. So in the first study, there was something really interesting that you mentioned as a takeaway, which was the ability that the users know about the system could be enhanced for a better experience of learning. So I guess the way I heard it, and correct me if I'm wrong, is the more the person knows about the system, the more the person would feel comfortable learning from it in case of a telepresence. So I think this is a question that I have even for robots in general, but in this case is how can we make lay users more acquainted with systems that are complicated or can be perceived as complicated if this is not their background. If you have studied that, or if you want to comment on this. Yeah.
Sure. One thing on this project that actually predated me was like a simulation environment or kind of an animated game for learning about telepresence robots. So at least one approach that we thought about in this space, especially thinking about the K through 12 classroom where kids might not quite understand what's going on, what this hardware is. Yeah. There's a lot of tendency to like tease or, you know, designate, isolate someone for being different. There was interest in kind of having a training regimen for getting used to telepresence. So the idea is, you know, maybe all the classmates of a student who's using a telepresence robot to come to school complete this training and get to know what is the technology, what's it for, what can it do. So that was one thing that they thought about even before I joined the project. Although I don't think that project sort of got to the finish line in terms of being evaluated on a large scale. I believe there's one paper that I could track down related to it. And in the more adult user case, I think in some of the deployments, the participants were still learning about new features of the robot as they were starting to use it in the classroom. And initial training that we did involved moving around a little bit with the robot, so they did get to kind of take control, drive around. But some other features like the zooming of the camera, maybe, let's see, I'm trying to think of other things people discovered later on. That one was definitely an important one to think about. Maybe even having a chance to operate the robot in a mock classroom space before they go into the actual classroom space to figure out things like, oh, I should really be in the front row if I want to be able to see the slides or board clearly. I think that would have helped and maybe would be a good best practice. The simulation environment in that case might be useful too, but I think a lot of the insights or surprises for students more had to do with video quality or placement of the robot. So moving around a physical space and trying to read something off the board may have helped quite a lot.
Mm-hmm. Okay, great. Yeah, that makes a lot of sense. And I'm thinking that the robot itself would be nice if the robot could also have an active role on this, like onboarding, right? Like the robot could somehow do that training by actually saying, I have these sensors, you can test them by coming in front of me for the camera, or just making this also part of the initial human robot interaction. So I myself have been thinking about that. So that's why yeah, thank you.
No problem. Thanks for the question.
Are there more questions? Go ahead, Philippa, you can unmute, yeah.
Hi, Naomi.
Hi.
So thank you for your talk, very interesting work. So the first two studies that you presented caught my attention. I was very, very surprised with the adaptation results. So I was trying to picture myself, like if I was in a classroom, for instance, in a telepresence robot. And I was thinking, this is not a question, it's just more like a suggestion and to know your thoughts about it. But do you think that maybe people feel so limited in terms of perception that the expressivity of the robot, it's kind of secondary. Because of course adaptation, I think it would be important, but in my example, when I was trying to picture myself, I thought that being limited in terms of perception, like I'm in a classroom, I want just to gaze my colleagues, my classmates, what are they doing? Are they chatting or not? Are they paying attention or not? And being so limited in those tiny perceptions that are actually not tiny maybe makes me feel, makes me care less about expressivity. What are your thoughts on that?
Yeah, I think you're hitting on an important point, which comes back to that. Like, if the camera quality is not up to par, and if the network connection is kind of having trouble, almost nothing else matters. Maybe that's not exactly true, but especially for the education setting, I think that's kind of paramount. So it's sort of a frustrating but central resounding theme of telepresence research. Those are such key central challenges. If you have a network connection problem, which we were lucky to have pretty good luck with our, our network connections, but also if the camera quality isn't quite good enough to begin with, those are super crucial things to solve before adapting beyond. We were using mostly, I should mention, the Beam Plus telepresence robots and Omni Labs Omni telepresence robot with the sort of Gen 1 camera. I know Omni has made some camera advance or rolled out a newer camera package since I used the robot too. So it's definitely worth investigating that one. It may be a bit better than the previous model. But the beam video quality was pretty limiting on students' ability to like follow along with the lecture notes. It seemed they really needed to zoom in and sit in the front of the class with their robot proxies. And with the Omni, the built-in camera was a fisheye lens, so I think just using that type of view in a learning space can be challenging. So those are really key things to think about, and I think something that maybe folks who are thinking more about network connections will help us solve. But yeah, definitely very crucial.
I also have another question. I think
Sure.
this is a quick one. So do you think that so you found that closeness with the cooperator or the teammate was important, but do you think it's also related to like how much you trust that the operator will be a good operator? Like, do you think that instead of manipulating the how much you know that person, if you manipulated like a biased information about the quality or the proficiency of that operator, if it would lead to the same result?
That's an interesting question. I'm not sure. So the closeness result was most important for the robot operator, not for the co-present person who is there in the same physical space as the robot. For that person, the closeness effect wasn't there actually. So for the robot operator, if they have a close relationship with the people who are nearby to the physical robot hardware, they'll automatically feel more present in the space. But the opposite actually wasn't true, perhaps because the sort of physical image, I see this as a robot here and not my friend, sort of disrupts that a bit more than for the robot operator, who's just doing sort of your standard video conferencing view-wise. So they see the space, they see their friend. The robot hardware itself maybe isn't as disruptive. So for the co-present person, it's definitely possible if we had like a rowdy, erratic robot operator versus a a more experienced controlled one, there might be some difference. I'm not sure it would be related to the closeness though, since there's already a bit of a difference in the two human roles in that system to begin with. Does that make sense?
Yeah. Thank
Yeah.
you.
I saw Kim.
Yeah.
Hey Naomi, I don't know if you can hear me well. My internet's connection is not great, so if there's any problem, let me know. First of all, I just want to say I really enjoyed the clarity and richness of your presentation.
Thanks.
How the different facets of the work really relate to your central, problem that you're trying to solve. So my question is related to kind of going forward in the field of telepresence robotics, kind of more generally. So this morning I got an email with a news article about this new project in which they were looking at holographic systems for kind of like, a proxy for people. So basically there was a teacher or professor with a green screen in the back, and they were recreating this person as a hologram in a classroom. And so this gets me thinking in terms of like us in robotics, what the value of the robot is, and if the role of the robot going forward should be what Telepresence has looked at so far, which is the role of a proxy. So meaning that the body should resemble the body of the human, the proxemic expression should kind of match what would happen in real life, that the nonverbal gesturing and all of that stuff, even the personalization, like should the robot wear what the person typically wears? So this gets me thinking if we wanna, if the role of a proxy is kind of the only one that a robot could have, or if the robot could act as a mediator perhaps. And if that is the case, how should a robot that is a mediator look like? So yeah, what are your thoughts on those two different roles? Yeah.
Yeah, interesting. I think this is a very multi-layer question. I would say, based on what I know so far about the telepresence robot role itself, I guess until we have a hyper-human-like perfect physical match, there seem to be pitfalls along the way. So I'm sure the wig presence and creepiness of a wig on a robot is just the tip of the iceberg there. If we added more features and degrees of freedom to telepresence robots that made them more and more like direct physical proxies of remote human operators, I'm guessing we'd run into more than just the wig problem. There would be a few pitfalls along the way, or kind of potential snafus. Although, perhaps we could get it perfectly right. I think that's a very tricky path. I'm not totally sure what I think about the uncanny valley, but I think there are some aspects of the snafus along that path that relate to that idea. Is there a feature that's too human-like, or maybe one part is human-like but another isn't, and it causes some tension and creepiness? The moderator or sort of helper idea is interesting. I think when I've seen robots used at conferences, telepresence robots, which is maybe one of the most common places I've seen these robots used with big groups of people, I think the difficulty of chiming in and interjecting and like striking up conversations with people there in the conference space is pretty real. So that's an interesting idea, the sort of moderator role. I do think in that application in particular that there's something missing to get people actually comfortable in interacting with telepresence robot users. So it might be that there's something in the way of another robotic agent that needs to encourage people to talk to the telepresence robot. I guess another option might be orienting people or having like a blended gather town or spatial chat session so that physically present conference attendees and remote attendees actually get to know each other a little better before you're just thrown in the fire with a more daunting physical telepresence representation where, at least based on what I've seen in those closeness results and what I've observed in real life, seems to be daunting. Breaking in that space seems to be pretty tough. So that's one area where it might be interesting to tinker. I don't know if another robot to like mediate and get things flowing is the right perfect answer. I imagine a person could do that too, like a student volunteer shepherding people over to talk to the robot.
I guess when I said mediator, I meant more along the lines of does the arm that manipulates object in the world need to also be gesturing, for example? So like if you have if you don't have this mapping between the arm of the robot represents the arm of the human, perhaps you could have like a whole body video of the human, and the human uses their hands for all the nonverbal gesturing, but then the arm is there as a tool and maybe is like on top of or somewhere that is not, that doesn't have a one-to-one mapping with the physical embodiment of the human. And I wonder if that would alter the perception of both the operator and the person interacting as well. And if that makes it more of a tool where you're not kind of liable for any mistake that you do by moving in the wrong place or extending your arm the wrong way and so on and so forth. So, just a question.
Yeah, that's interesting. The space of telepresence is also so weird and tricky because you have a robot, but it's also human operated. So some ideas of autonomous robotics might apply. I didn't undertake any of this work, but I know other people have thought about it in the past, sort of the blended autonomy. Can we automate some of the robot's motion, but still have a human designating overall where it should go or what it should do? Is that helpful? Is the experience good? So an additional helper arm might fall kind of into that semi-autonomy space that I haven't ventured too far into. But there was always that weird tension. You could see in my study designs, like you often need pairs of people, or maybe you can do it with a confederate. Since there's a person actually controlling the robot, it doesn't make sense to make it fully autonomous. So there might be some sort of tricky space around an extra robot appendage that helps out in terms of, does it feel like I'm actually controlling it? Is it doing weird other stuff that I don't want it to? But I can't quite say, I think, without poking around more.
Thanks.
Okay, thank you so much, Naomi, for being here with us and for your amazing Q&A and discussion. Naomi is gonna go to Slack or be there present and reply to any of your questions. So what we will do is to create a channel dedicated for Naomi's presentation where you can just drop your questions there, and then when it's convenient for Naomi, she can just jump in and engage with you. So thank you everyone for being here today. And I look forward to see you in the future. Before we leave, I just want to let you know who the next speaker is gonna be. So in the next session, we will have Homanga Baraja. I don't know if I said it correctly. He's going to talk about learning reinforcement learning policies adaptive to variations in the environment. And this work was presented in ICRA this year, so it's very, very freshly baked. A curious fact about the next speaker that I want to share, it's about his name. So Homanga actually means part of a flame. So for those that are into, meaning of names, you can just read about Homanga's name on his website. I swear I did not invent this. And that's it. Thank you for being here and have a great day.